Hello and welcome to Chinta's YouTube channel. Today we'll be discussing the AIME 2021 problem number 11. This problem involves the concepts of similarity, cosine law, means the properties of triangles. It talks about cyclic quadrilateral and it has an application of Ptolemy's theorem. So we'll be reviewing all this concept while we'll be discussing the solution of this problem. Let us try to understand the problem statement first. So we are given a cyclic quadrilateral ABCD. So I have taken a circle. ABCD are points lying on that particular circle, and we have joined the diagonals AC and BD. Then from A and C, perpendiculars AQ and CS are dropped on BD, and from B and D, perpendiculars BP and DR are dropped on AC. Now we have these 4 points PQ, we have these 4 points PQ, R and S, we have joined them to form another quadrilateral, and our goal is to find out perimeter of this smaller quadrilateral. So first of all, to make some observation in this problem, my claim would be that there are a bunch of cyclic quadrilaterals. I'm not talking about the given one, I'm not talking about ABCD, I'm talking about some other cyclic quadrilateral present in this figure. So if you cannot identify them, let us review some of the properties of cyclic quadrilateral. I think after that you will be able to identify the cyclic quadrilaterals which are present in the diagram. So the first thing is that opposite angles, this is a very well known fact that opposite angles in a cyclic quadrilateral are supplementary. What does that mean? That means sum of the opposite angles is equal to 180 degree in a cyclic quadrilateral. Okay, that's the first thing. The next thing is, if you have a structure like this, there is a line segment, let's call it XY, and there are 2 points, maybe P and Q, and we have constructed angles like this XPY and XQY, and we know that these two angles are basically same, then XPYQ would be lying on a circle. Why is that true? Because we know this theorem, this is a very well known theorem, that if angle subtended from a arc in a circle are all equal. So using the converse of this theorem, we can say if two angles are equal which are subtended from a line segment, then this particular line segment XY must be a chord of this circle and PQ must be 2 points on that circle, and that is why these two angles are equal. So that means there must be a circle which is passing through all these points PQ, X and Y, and that makes PQXY is a cyclic quadrilateral. Now I think you will be able to figure out what are the cyclic quadrilaterals here. If you notice carefully, the angle APB is equal to angle AQB. Why is that true? This is because of this is by our construction. Both the angles were 90 degree. So both are right angles by construction. Both are right angles by construction. So using that property that we have just seen, we can say that APQB is a cyclic quadrilateral. APQB is cyclic. That is the first thing that we have. Okay. Now my claim is that DSRC is also cyclic. And why is that true? If you know, you can comment down your argument in the comment box. DSRC is also cyclic. This is also cyclic. Okay. Now what happens if these two quadrilaterals are cyclic? I'll make another claim and we will also prove that eventually. My claim is that triangle XPQ is similar to triangle XBA. Now why is that true? Let's see that first of all, if you notice, we have one angle which is very clear. It's common angle. This is a common angle here. Which angle? I'm talking about this one. You see, if I take this angle as some theta or something, then theta is present on both the triangles. It is present on XPQ, it is present on XBA. So we already have one angle. Okay. So now to show that these two triangles are similar, we now need to find out one more angle, because we'll be using the angle-angle criteria of similarity of triangles. So another angle, my claim that the other angle we are trying to find out, which are equal, should be these two angles. This angle here, XPQ, this angle, and XBA, these two angles are equal. Now why is that true? Let us try to prove. This is true because, okay, let me try to write, first of all, theta is common. That's the first conclusion. And second conclusion is angle XPQ is equal to angle XBA. We haven't proved it yet, but we will. Why is that? Why these two angles are equal? See carefully that we already have seen that opposite angles in a cyclical laterals are supplementary. So using this thing, using this fact, I can write that angle APQ plus angle XBA is equal to 180 degrees, because we can easily see that there are two opposite angles of this cyclic quadrilateral APBQ or APQB. Similarly, APQ and XPQ is also 180 degree. Why is that true? Because APX, they are collinear points. APX are collinear. Because we know that they all are points lying on that diagonal AC. So they are collinear, and the angle formed at P must be a straight line angle which is 180 degree. So using these two relations, we can easily say that XBA is equal to XPQ. So we are done. We have proved that these two angles are similar. Now, if these two triangles are similar, then what happens by that? We can conclude their corresponding sides are in same ratio. So we will be able to say XP over XB will be equal to XQ over XA, and that is equal to PQ over AB. That's fantastic. Now we will take this one more step ahead. My claim is that this thing is equal to cos theta. Remember that we have taken this PXQ angle to be theta. Let me write it. Angle PXQ is equal to theta. That is taken as theta. May not be visible in the diagram properly. So that is taken as theta. Now why is that true? Notice this triangle. Okay, let me change the color here. Notice the triangle BPX. In this triangle, we can easily see that is a right angle triangle, and cosine of theta is base over hypotenuse, where hypotenuse is the side BX and base is the side XP. So it's nothing but XP over BX. So this ratio is particularly equal to cosine of theta, and all other ratios are equal to this ratio. So all the ratios are equal to cosine of theta. Okay, that's a very important thing that we obtained here. We will need that later, so let's box it out. Okay, fantastic. Now I'll directly make a claim, and you need to tell me why this is true. My claim is that the triangles XSR and triangle XCD, they are also similar. Find out why this is true, and if you can, please comment down below. Now, as we know that these two triangles are similar, again we can say, okay, so the sides must be in same proportion. So we can say XS over XC must be equal to XR over xd, which must be equal to SR over CD. And this is also equal to cos theta. Why is that true? Because you see that angle SXR is also theta. Why? Comment down below again. This is very easy to get. This angle is also theta. Now, if this angle is theta, we can again consider a right angle triangle. Maybe we can consider the triangle. DXR, and in that triangle we will find out that cosine of theta is nothing but, here dx is the dx is our hypotenuse, and xr is the base. So basically xr over dx is our cosine of theta, and which we have here. So this must be equal to cosine of theta, and all these ratios are equal to cosine of theta. Okay, so that's another conclusion that we found out. Let's box it out. Okay, now my next claim is triangle XPS is similar to the triangle XBC. Now why is that true? If we can somehow prove that two of its sides are in same proportion and one of the angle is equal, means the angle which are holding these two sides are equal, then we are done. That is called the SAS criteria of similarity. So using SAS we'll be proving it. So basically, first of all, you see XP is a side of XPS triangle and XB is a side of XBC triangle, and we can see XP over XB is equal to cosine of theta. Let us write that. XP over XB is equal to cosine of theta. Okay, again XS is a side of XPS and XC is a side of XBC, and that ratio is also cosine of theta. So let's write that again. So that is equal to XS over XC. So these two ratios are indeed equal. And if you notice, angle QXR is equal to PXS. Why? Because both the angles are pi minus theta and they're equal, because both the angles are pi minus theta, they're vertically opposite angles, right? So they're basically vertically opposite angles. So using these two, we can say these two triangles are similar, and we can conclude that all three sides must be in same ratio. So these two sides are already in ratio, and with it we'll also get the third side, which is PS over PC. That will be in the same ratio. And we can also conclude that all these ratios are equal to cos theta, because we know XP over XB, XS over XC, they were already equal to cos theta. So now, similarly, by the same argument, I'll not do that again. This will be your task. If you can show that why I'm writing this, please comment down below. So I'll be writing similarly the triangles XQR. Maybe I can move down this diagram a little bit. Okay, let's move it down a little bit. So XQR triangle, XQR must be similar to triangle XAD. Okay, I'm just assuming that this is true, and indeed it is a true. You can comment down below why this is true, why they are similar. Now, as they are similar, we can conclude that their sides are in same proportion as well. XQ over XA should be equal to QR over AD, and that should be equal to XR over XD, and this ratio should be equal to cos theta. Okay, so we have four things now. We have four things. These are the two relations that we have and these two relations. So from the first relation, if you notice that we have PQ over AB is equal to cosine of theta. PQ over AB is equal to cosine of theta, which can imply that PQ is equal to AB cosine of theta. Similarly, from the next one, we can conclude that SR is equal to CD cosine of theta. From here, we can write PS is equal to BC cosine of theta, and from here we can write XR, or rather QR is equal to AD cosine of theta. Now let us add up all these things, all these relations, these four relations. So if I add up all these four relations, in the left hand side what I get actually, let us see. PQ. What is PQ? PQ is the side of the smaller quadrilateral. SR, what is SR? That another side. PS, the third side, and QR, the fourth side. Okay, so that's the perimeter. That's the perimeter of the smaller quadrilateral. And in the right hand side, what I'm getting? I'm getting, so the perimeter of PQRS is equal to what I'm getting? AD cos theta plus BC cos theta, AD cos theta plus AD cos theta plus BC cos theta plus CD cos theta plus AB cos theta. So if you take out cos theta common, you get AB plus CD plus BC plus AD, which is nothing but the perimeter of the actual quadrilateral, which is 4 plus 5 plus 6 plus 7, which is 22. So we can write this is equal to 22 cosine of theta. So you see, we have found out the perimeter of PQRS, but not completely. We still have some cosine of theta left. So we have to figure out what is cosine of theta. Now this will be very easy if we know how to apply cosine law on these triangles. So what is cosine law? Let us quickly review. In a triangle, cosine law is nothing but, let's say if we are given a triangle ABC, where this side is A, this side is B, and this side is small c, their lengths are taken like this, then we can say three things. We can say B square should be equal to A square plus C square minus twice of AC cosine of the angle B. Similarly, you can say C square should be equal to A square plus B square minus twice of AB cosine of angle C. And third, A square should be equal to C square plus B square minus twice of BC cosine of angle A. Now using these properties, we can find out some relations on theta here. So first of all, from the triangle, let me just copy the diagram one more time. Okay, so from the triangle XAB, we can say that AB square, which is basically 4 square, is equal to AX squared plus XB squared minus twice of AXXB cosine of theta, because we know that the angle between AX and XB was taken as theta. Similarly, I can write from the triangle XDC, I can write 6 squared is equal to xt squared plus xc squared minus twice of xdxc cosine of theta again, because that angle between xd and x is also theta, because that is a vertically opposite angle. Okay, fine. Now let us add up these two relations, and what we get, 4 square plus 6 square, that is 16 plus 36, which is 52, is equal to ax square plus b square plus x c square plus x d square minus twice of cos theta a x xb plus xd xc. Fantastic. Let's keep that as an equation. Let's write that as equation 1. Now similarly, applying cosine law on other two triangles, on the triangle, okay, let me just copy that diagram one more time. So on the triangle, applying cosine law on triangle XAD, we will get 7 square is equal to XA square plus XD square plus, minus twice of XA times XD cosine of pi minus theta, because the angle holding them was pi minus theta. But we know cosine of pi minus theta is equal to minus of cosine theta. Why is that true? You can comment down below if you already know. So replacing that with negative cos theta, we'll get a positive sign here. Similarly, from the other triangle, from XBC triangle, we will get 5 square is equal to x b square plus x c square plus twice of xb xc cosine of theta. That will be plus because the angle was again pi minus theta. Now if I add up these two relations, what I get? 49 plus 25, which is basically 74, which is equal to again xa square plus xb square plus xc square plus xd square plus twice of cos theta common, xa times xd plus xb times xc. Fantastic. Let us write it as 2. Okay, now let me just copy this equation 1 here. Okay, so this is our equation 1 and this is our equation 1 and equation 2. Now from equation 1, if we subtract the equation 2, what we get? From equation 2, if we subtract the equation 1, what we get? All these terms such as xa square, xb square, xc square and xd square will just vanish. They will cancel out. And whatever things are remaining, they will be there. Okay, so let us do this simplification. So we'll get 74 minus 52, which is just 22, which is equal to, these terms gets cancelled. We can take a 2 cos theta common, and what are the remaining things? xa times xd plus xb times xc plus ax times xb plus xd times xc. Now let us do a little bit calculation here. We can just easily write this is 11 because we can just cancel out 2 from each side of this equation. So this becomes 11 is equal to cos theta times, if we take ax or xa common from these two, we get xd plus xb, plus if we take xc common from these two, we get xb times plus xd again. Okay, so again let's take xb plus xd common from here and we get xd plus xb times xa plus xc, and that is equal to 11. So this is nothing but cosine of theta. You see, xd plus xb, what is that? Xd, x to d and x to b adds up to the whole diagonal bd, and xa and xc adds up the whole diagonal, it adds up the whole diagonal xc. Fantastic. So this is nothing but ab, or rather bd times ac. Okay, now we have to find out product of the diagonals of this particular cyclic quadrilateral ABCD. If we can do that, we are done. So now here comes the Ptolemy's theorem. Ptolemy's theorem said, Ptolemy said that, okay, if you have a cyclic quadrilateral where you know the side lengths, let's say for our example ABCD is a cyclic quadrilateral, then AB times CD will be product of the opposite sides and their sum. So B times, sorry, we actually know, we want to find out AC times BD, and that would be equal to, this is the product of the diagonals, that would be equal to the product of the opposite side. So AB times CD, that is this is the product of two opposite side, plus what we have, BC and AD. Fantastic. BC and AD. So basically this gives us AB and CD were respectively 4 and 6. So 4 times 6 plus this was 7 and 5. 5 times 7. So 24 plus 35, which makes it 59. So this is 59. So using Ptolemy's theorem, we got this value is nothing but 59. So which makes cosine of theta to become 11 over 59. And we already know perimeter of our required perimeter of perimeter of PQRS, sorry, PQRS was 22 cosine of theta, which is equal to 22 11 over 59, and if you do the simplification you will get it as 242 over 59, and that is our final answer. Thank you for watching this video. Just put down your answers that for the questions that we have given you in the comment box, and we will meet very soon in the next video.